ladies and gentlemen, you're most welcome once again. Hassan Rixok as usual. I'm available to take through this part here. But what you should know that don't forget to subscribe, like, share. Go to the comment section right there. Your question that you want to ask, I'll be able to respond to it. Or else you can WhatsApp me on 0758876705. I can also answer questions via emails dixocastle07@gmail.com. I'll be able to get you and we shall be able to chat. You can partner that. Today, we have been looking at very many concepts. We are still continuing with complex numbers, but still we have been looking at concepts. Today, we want also to look at a certain concept. We are calling it argument of a complex number. We want to know what we call an argument of a complex number. What is that part that we are calling argument of a complex number? We have a complex number, and the last time you saw how it was done. So, we shall always put a complex number on what we call an Argand diagram, of which to get an Argand diagram, we shall also look at that. We shall also look at the way how we can represent a complex number on an Argand diagram. But ideally, I always wanted people that whenever we go to what we call an argument, you must have the concept of an Argand diagram in the head. You will represent the complex number on the complexity plane. After representing it on the complexity plane, what you will get is what we call an Argand diagram. The complex number will be inclined at a certain angle, and we shall look at that. That's where we shall base, and we know what we call an argument. So let us assume that Z is a complex number. If Z is a complex number which is equal to x plus yi, we shall represent this one on a complex. Let us first have a complexity plane with the real axis, also imaginary axis. So what are we able to get? This is x, and this is y. Like that. So what are we having? There is this angle that we are making with the horizontal, with the positive real axis, this one here. So in this case, we are calling it theta. So if this is x and this is y, we are saying that this is r, our modulus, or our length of the complex number. So how can you get this angle here? You can say that this is tan of theta, which is opposite over adjacent. So tan of theta is equal to opposite. The opposite is x. So this angle is y, and adjacent of this angle approximately is x. So we are saying that tan of theta is equal to y over x, whereby theta is equal to tan half of y over x. Theta is equal to tan half of y over x. In this case, we are saying that theta is our argument of this complex number. That's the angle that we are making. But there is what we call argument and what we call principal argument. When you are in this quadrant, someone in this quadrant can be lucky that the moment you get this one, the tan half of y over x, this one just becomes the principal argument. But what is the range of the principal argument? Before you can be able to interpret this, you must know what we call the range of the principal argument. Before we state the range of the principal argument, what we are supposed to know that the principal argument is unique. It is very unique. It is always one like this. If someone gets this theta here, someone is looking for tan or theta, depending on trigonometry, is it positive or negative? So for this one here, someone is interested in tan of theta from here. But still someone can move up to here, which is 360, and add the theta. You reach 300, 200, 720, you add the theta. They are all angles and they are all arguments of that complex number. But we are saying that if they are all arguments of the complex number, we are saying that theta is an argument in this case. Let us write it here. This is 0 degrees. 360 here, 90 degrees. Then this is 180 degrees. This is 270 degrees. If you rotate up here 360, 250, like that, you come up to here 200 what? 720. Now, if you reach here, you can see that if I have my theta here, this is my theta. Let me see that my theta is 45 degrees as my theta. Now I'm saying that theta is an argument with that complex number. I can also solve it and I reach 360. So I began with 45. Now when I reach 360, I will say that 360 plus 45 still to get another argument. I will rotate and I reach 720. 720, then plus 45 still. That is also another argument of that complex number. But shall we write all of them? We are saying no. When we are here, for us we are always interested in what we call the principal argument, which is always unique. It is always one like this. It will not be. So how can you get the principal argument? The principal argument will always lie in the range. It will always lie within that range. It will always lie from negative pi less up to less pi, negative pi less theta less or equal to pi. What does it mean here? It is a closed interval this side is an open interval, whereby this negative pi is not included. So in case you on that axis, the negative pi is not included, we take the positive what? 5. We always put this one into positive. Or someone can write negative 180 degrees up to 180 degrees. In this case, 180 degrees positive is included, but negative 180 is not included. You must know that one, and you must put it into post direction. So, if you get all of these angles just like how we have been getting them, and you say that they are arguments of the complex number, you only, among all of them, you only find one angle like this that will lie within this interval. It will only be one angle like this that will lie within this interval. So, if you find that angle that lies within this interval, it is the one we are interested in, and we always call it the principal argument. This is one of the reasons why we say that it is very unique. It is very unique because it is not possible to find two of them here. You only find it alone within the range that you are interested in. That's why we say that it is very unique. So it is that principal argument that you need to look for, and we call it the argument of the complex number that we are interested in using. So after getting this, that's the range. In that case, we can also look at what we call examples, and you see what we are saying. You can find the argument of the complex number below, whereby we are saying that z equals 4 plus I, and z equals 4 minus I. You can, this is Roman number 1, Roman number 2. We can consider the two, and we are such that we can consider the two to be able to get the argument of the complex number. How can we do this? We are saying that this is solution. Roman number 1, z equals 1 plus 4 plus I. So how can you do that? Just one thing that I forgot to tell you, that the moment you finish representing your complex number like this on the Cartesian plane, this one here becomes what we do. This one becomes an Argand diagram. It doesn't need you to look for something. This one is the Argand diagram. So after having your Argand diagram, so for you to be able to get the principal argument, you must be able to illustrate the Argand diagram. So after illustrating the Argand diagram, you depend on it to get the principal argument. So in this case, we are saying that we are looking at Roman number z equals 1 plus I. You go and illustrate the principal Argand diagram. This is the real axis. Please, we have real axis, not x-axis. Imaginary axis. is at a certain angle, we are calling it theta. And where we are having this, we are saying that this is 1, this is 1. So tan of that theta is equal to opposite over hypotenuse. Opposite is 1 from here. Then this is adjacent. Opposite over adjacent. That is tan, opposite over adjacent. 1 over 1. So theta will be equal to tan up over 1, whereby theta is equal to 45 degrees. So we are having 45 degrees. Now you come and see. Is the 45 degrees within this range? Yes, it lies within this range. Therefore, we subtract that one as the principal. There is no any other angle after when you get it that will lie within this range. If 45 lies within this range, just that there is no any other angle that will lie within this range. So this one becomes the principal argument. So after getting the principal argument, we always advise people that take it to radians. It is always advisable to take it to radians. So after taking it to radians, you see that theta will be equal to, how do you take it to radians? You get the angle times pi over 180. 45 degrees times pi over 180, which is pi over 4. So you are getting pi over 4. This one is our argument in that case. So you conclude by saying that our argument. So how do you write it? You write it as arg. You can abbreviate it as arg, or z will be equal to pi over 4. So the argument of a complex number can be written as arg, or z, which is equal to pi over 4. So after getting it, you can be able to finalize with it. So how can you be? You see that Roman number 2. Which is z equals 1 minus I. So z is equal to 1 minus I. So how can you do that if it is 1 minus I? The 1 minus I, you can continuously look at 1 minus I, that case, and see that if it is 1 minus I, this is our x and minus I, minus 1 is our y. You can put on another diagram. Real axis, imaginary axis. If you have the real axis and imaginary axis, look at it and see. 1, negative 1 is down. You plot the angle that we are interested in is that angle there. We shall have a final conclusion at the end and you see what we are meaning. So tan of theta, opposite over hypotenuse. Just take the positive part, don't put the negative. So 1 over 1 is 1. So theta here is 45 degrees. In this case, our theta is 45. But how are you measure this angle in the anti-clockwise way? So in the clockwise direction, of which that angle is supposed to be negative. So we are saying that theta is equal to negative 45 degrees. So here, theta will be equal to negative 45 times pi over 180. So theta is equal to negative pi over 4. So if you have so you can also go ahead and say that arg of z is equal to negative pi over 4. So why am I writing like that? There is one thing. There is one thing that everyone is supposed to know, that whenever you are getting the argument, the principal argument is that angle that you measure from the positive real axis. What's the positive real axis? If you look at this diagram here, when you are moving this side, this is the side of the negative, and then this is the side of the positive. So this is the real axis. So from this side, this is what we call the positive real axis. Then this is what we call the negative real axis. So we are talking about the positive real axis. That's where you measure the angle. So even if your complex number is lying here like this, the angle we want is from here up to where the complex number is. That's the angle we want. That's the one we call the positive, the argument. It is that angle we measure from the positive real axis, but you must be able to locate it within the range. So after measuring it, because there is this angle here and also this angle from this side.